Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we are going to start talking about what happens after you verify that there was in fact some sort of a breach. So in the previous video, we detected some anomalous behavior, and the next thing you need to decide is, should I take the system down or not? And it really depends on the situation. Now, based on my interview with the users, which of course I recorded in my bound notebook, I know that this system in question is actually a developer's workstation. So if I take that down, it's not like people are going to lose business. You know, the developer might lose some productivity, but we need to investigate what happened. So we'll pause for a second, and I just wanted to show you some things that you could do if you are forced to deal with a live system and you need to do some additional study. So we talked about how you can send files that are suspicious over before. For example, we noticed in a previous video that this system had users that shouldn't be able to logging in. So we might want to investigate things like bin false. Has somebody altered that somehow to allow people to log in that shouldn't? Other things that we can look at. So here's a couple of simple scripts that I've written that you could use if you're forced to do some sort of live response. You have a system you just can't shut down or not shut down for very long. Now, note that the longer the system is up and running, the lesser the chances of your getting some good evidence collected in order to catch whoever did something. So here, this first one is called send file info, and it's just a simple script. And what it does is you give it one parameter, a starting directory, and then for everything under that directory, it will print out a bunch of file information in a semicolon delimited file. This is handy if you want to import this into OpenOffice, Calc, or something similar for some later analysis. You want to sort by dates, etc. And the reason that I gave it a parameter of a starting directory is, if you do this on the entire file system, it's going to take a while. And you might not really need to do the entire file system either. So this allows you to do just a little bit, whatever you think is appropriate. And this script is primarily here in this one line. So I'm going to log, I'm calling my logging script, and I'm doing a find, and I'm starting wherever you told me to start, and I'm going to print out some information. So the information that I'm printing here is the access date, the access time, modified date, modified time, creation date, creation time, file attributes, the user ID, the username, group ID, group name, file size, and the file name. You can get all this information, incidentally, if you wanted to do something similar but a little bit different, by looking at the man page for the find command. And it'll tell you what all of these different flags mean, all these different tokens. Another thing you might want to do is you might want to collect all of the log files. So I wrote another simple script for that. So here, I don't take any parameters, and it calls send log shell again. And I'm using another find command, and I'm doing a find from var log, where the logs are normally stored. And I'm only interested in files, and I'm going to use a regular expression, and I'm going to use a POSIX extended regular expression that lets me use some of the features that I wouldn't normally be allowed. Let me scroll this up here a little bit. I will search for var log and then something that contains only letters and possibly a period. In other words, I don't want things like old log 1, old log 2, etc. that might be stored, at least not for now. And to that, I have at least one of those. And to that, I will add a slash and the same thing again, at least one of those. And that could be repeated. Right. So this eliminates all of those files that are backups. And I will call exec, and I will echo that I am dumping a certain log file. And when you're using find like this, the brackets are replaced with the file name. Then I do another exec and I cat the file. And then I do a final exec and I cat end of dump for log file. And this will put all of this into my log. Again, this might take a while because you'll go through several logs, literally every log on the system. Another useful thing you might want to do, looking at the history. What was each user doing on the system? So how do we do that? Again, we're going to use find. So first we do a find on the home directories. We're looking only for files. We're again using a regular expression. And I'm going to look in home slash and then some user ID, at least one of those, and then slash, and then dot bash history. Now, it should be noted that if they're not using bash, if they're using some other shell, you will not necessarily get their history file with this script. But bash is the most common shell that's used for Linux systems. So you might need to adjust this somewhat if you find that people are using a different shell. And again, this is just a preliminary thing to do on a live system. And we do the same thing here again. We just echo a banner at the start, cat the file, echo a banner at the end. And then I also repeat this using /root, the admin user's home directory. Again, this is the default value. If you have a non-default value on your system, you would have to adjust. Finally, the last script that I wrote here that might be useful is called send SHA-256. So what this will do is it takes one parameter, again a starting directory, because you probably don't want to do the entire file system. You know, maybe just something you suspect has been changed. And for every file that it finds that's an actual file, the -xdev option here for find says do not descend into other file systems. So if there's a link to another file system, don't go there. And execute SHA-256 sum on a binary file, and here's the file name. Incidentally, if you wanted to use something like an MD5 hash, you could just substitute MD5 sum. Normally, I do not like to use MD5. It's not considered cryptographically safe anymore. There are some people, however, that like to use it. And you might find a bunch of MD5 hashes for good binaries and not as much for SHA-256 values. So that's just a little note how you could change that. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you next time. Hello, everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue our discussion of live analysis, and we're going to talk about dumping RAM. As a reminder, our high-level process looks like this. We finally got out of box one, if you will, and now we've decided, yes, there was an incident, and this situation deserves a little bit more attention. So we're going to do some live analysis. So one of the first things we want to try to do, we've already collected a little bit of information in order to get to this point, and now we're ready to dump some RAM. Now, there's always a chance when you dump RAM that the machine might crash or something bad might happen. So you might want to gather a little bit of preliminary information first, but in this video we're going to talk about dumping RAM. Back in the old days, in the simpler times, if you will, it was easy in Linux to dump memory. There was a device called devmem that could be used to just dump every bit of memory. And there was another device called devkmem, which would dump virtual kernel memory. Why did these go away? These went away because they were a huge security hole. So you had this userland device that pretty much anyone could access, and you could access all of the memory on the machine. So this was a bad thing from a security perspective. So now these have been disabled or limited or just pretty much removed from any Linux that you're likely to encounter. If you can find a machine that still has devmem, it's limited to the first 896 meg of RAM. So you can't even get a gigabyte of RAM out of it. Now, if you're running a 64-bit Linux, there's absolutely no chance that you can use these devices. So what are you going to do? Well, the hard way. You can acquire memory images from a modern system is to create a new device that acts just like the old mem device. And this new device is called fmem for forensics memory. And if you go to this link I provided here, you can download the code for this. It's pretty easy. You do a sudo make install, and then it works just like devmem used to. You can treat it just like a file. It's a little bit hard to work with, however, and there are a couple of issues. By the way, you should never be building the software on your subject computer. Obviously, this is going to cause some changes that you probably don't want to occur, especially changes in memory, which is kind of what you were after. You could build this on an identical architecture machine or in a virtual box if you don't have the same kind of system. Once you've built this, you can use the proc IOMEM information in order to determine which chunks of memory are interesting. Now, there's a couple of issues with this way. It's hard, it's very manual, that's one thing. And another thing that you'll run into is the fact that you won't have an image that's usable by things like volatility. And really what you'll have is an image that you can use for some simple searches, and that's pretty much about it. So that is the hard way. The preferred way to get memory is to use LiME, the Linux Memory Extractor tool. Now, some things you need to know about LiME. It's a great tool, but it must be built for the exact same kernel. And again, don't build this on your subject machine. If you have an identical version of Ubuntu to what the subject machine is running, you can do this super easy. You can just run sudo apt-get install lime-forensics-dkms. This will build and install LiME for you. So for every other situation, you need to go to the GitHub for LiME. By the way, those of you who might have read a book, a very good book called The Art of Memory Forensics that came out recently, all about how to use volatility, you might note that they have outdated links in that book, which is not surprising given how books are made and how long it takes. Here's the current link. You go ahead and compile it. Now, we'll show you a little bit later how you can do this. And the only thing you need to know is if you're not compiling for the same operating system as what you're currently running, you just have to tell it where to get the right kernel headers. All right, other things you have to do with LiME. You have to pick your format. It supports multiple formats of output. So raw is the most basic form, and what they do is every chunk of RAM that they get, they just concat it all together. So if you're just doing some simple searching, this is probably fine. There's also padded. Padded is the same thing as raw, but wherever there were gaps, maybe some reserved areas, instead of concatenating everything together, it puts in zeros for those areas. And there's the recommended format of LiME. The LiME format contains metadata. And essentially what it does is it stores your memory output in a structure. That structure has metadata embedded inside of it. You also have to pick a destination. The two most common destinations would be a file or a network port. If you're going to put it out to a file system, again, do not put it onto the subject file system. You could put it onto a thumb drive if you have one large enough, or even better, onto a hard drive. I say even better because, as we all know, thumb drive write speeds are horrible. If you put it to a network port, you just use a netcat listener on the other side, and off it goes. And the general syntax for using LiME is just sudo insmod, insert module, whatever your LiME module is called, and then you give it the parameters path equals wherever you're setting it, and format equals your chosen format. And that's pretty much it. So it's very simple. Well, that's all for this video. In the next video, we will go and show you how to actually use LiME and some of these other tools. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone. Welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to show you how to dump some RAM. So I first wanted to start out by talking about fmem. Now, as I said in the previous video, fmem is a tool that you can download, and it will allow you to create a device that operates just like the old devmem device. So here I am in the directory. It's pretty simple to use. I can just make it, and it should go ahead and build my module. And once that's done, I can either do a sudo make install, or I could just do a sudo run sh. But of course I have to give it / because root does not have the current directory in its path, as it shouldn't. All right, so now it has created my new device and it's giving me a little bit of information about the different chunks of memory. How can I get some more information, something else useful? And let's just verify that in fact it has created my device, and it's only usable by root, but it's there. If I want to see what parts of memory are interesting, I can cat proc iomem, and it will give me a bunch of information about different parts of my memory space. Now, a lot of this stuff is not terribly interesting. So if I just want the interesting bits, I can pipe this to a grep for system RAM. And this will give me just the interesting parts. And you'll see that there are, in fact, 5 chunks that I'm interested in. So how could I go about collecting these 5 chunks? I could use something like dd, send this to a file. If I send it to a file, again, please send this to an external file system, not the one under study. And again, don't build this under the subject system either. So that's fmem, and fmem is pretty simple. But again, you're going to get a raw image that is not terribly easy to use. So let's talk about LiME. If I want to use LiME, after I've downloaded it, if I go to the source directory, if I want to use LiME for my current operating system, again, this is if it's identical to the target. It's not for using this on the subject machine. That's a very bad idea to be out compiling stuff. So here, I will assume it's the same. In my case, it's actually not. If I do a uname-a, you'll see that I'm running a 318 kernel, whereas my subject system is running a 316. But let me just show you how easy this is. So if you're using the same system, just run make. And it will go out and run make, and it's done. And notice at the very end, it says, I have moved your LiME KO file to this place. All right. So that's all you have to do in order to build for your current system. If I want to make for a different kernel, I just run make -C /lib modules 3.16.0, and we'll go with -31 generic. I think that's the right architecture for my target. And underneath this, I need to go to build. All right. So that's the full path that I need. Lib, modules, my kernel version, build, and then I say M, again capital M, equals $pwd. I run my make, and it's been built. Now, one thing to note here, it has not renamed my LiME file. So I'm going to go ahead and do that manually. I'm going to move lime.ko to lime-316.0.31 generic. just to remind myself, -.ko, that is the updated version. So now you see I have two LiME files. And I can do this for other kernels as well. Well, that's all for this video. In the next video, we'll show you how to actually use LiME to capture from your virtual machine. We'll see you then. And remember, as always, if you're enjoying these videos here at Pen Tester Academy, please tell your friends and help us spread the word. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to show you how to actually collect RAM with LiME. So I've already booted up my virtual machine, and as a reminder, if you are mounting a thumb drive inside of it, you have to go to Devices, USB Devices, and make sure you tick that thumb drive. So I've added my LiME modules to this thumb drive. You can see there's a couple of them here. Now I need to check and see if I have an appropriate module. And I should already know this because earlier I collected the information from uname, and sure enough, here's my module for the kernel 3.16.0-30 generic. All I need to do is insert the module. The module I want is LiME-316-030-generic KO, and I will give it a path equal to TCP:4444, and I will give it a format equal to LiME. Now it will sit and it will wait, and on my forensics workstation, possibly under my cases folder, I will just do this. I will say netcat 192.168.56.101.4444, pipe that to ram.lime. And off it goes. This will take just a couple of minutes. It will vary depending on the speed of your network and also the size of the RAM in your target machine. So I gave this target machine 3 gigabytes of RAM. So this should dump all 3 gigabytes. And again, it's going to put it into a structure, and it's also going to do some compression for me. So this file should, in theory, be less than 3 gigabytes long. So once this is collected, for now, we're just going to put it to the side. And in later videos, we will show you how to use volatility to actually look at this information. And there you have it. It's already done. So if I do an ls-l, I will see that, in fact, this file is a little bit over 2 gigabytes long. And that's all you have to do. So it's pretty simple to use LiME. Again, try not to compile LiME on your target system. And also make sure you have an identical kernel. And if you don't have an identical kernel, you could easily copy the file. So if I go back to my subject system here, the files you're looking for under lib modules, if you do an ls, you should see your kernel version or versions that have been installed. And if you simply copy this directory structure. You should really only need the stuff below build, but it probably wouldn't hurt if you just copied it at this level. That way you would also have a nice name. If you want to store a bunch of these out on a disk somewhere, you would know exactly what each kernel version was. Incidentally, this system keeps popping up little warnings saying that a system problem was detected. Do you want me to report it? And that's further evidence that there might be a rootkit installed or something else that's causing the system to act strangely, which is why they called you in the first place. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you next time. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, I wanted to talk a little bit about shutting down the subject system. Just to review, somebody called us and said, I think there's been an incident. And we said, yep, there sure was, based on some limited analysis that we did. And we did a little bit of live analysis, and now we're deciding, do we want to do dead analysis? And in this case, the subject system is not so critical that we want to risk leaving it up in order to determine what happened and possibly losing some evidence along the way. So we're ready to shut it down, and then we'll look at acquiring images as our next step. So before we shut it down, what should we do? Well, recall that we do have a memory dump. Now, we might want to do some last-minute scans, anything you can think of that might be easy to do while the machine is still up and running. You might also want to repeat some of those scans that we did and stored on our forensics workstation. Then you have to decide, do I want to do a normal shutdown or just pull the plug? So a normal shutdown, what's an advantage of doing it this way? The file system should be clean. You won't get any warning saying, hey, this file system was dirty. Downside of a normal shutdown, if you have some sort of malware installed, which we certainly suspect in this case that we do, it might clean up after itself and or destroy some evidence. So that might be a bad thing. What about pulling the plug? If we pull the plug, the file systems might not be clean. That is, things like caches might not have been flushed. We can mitigate this somewhat, however, by calling sync before we pull the plug. An advantage of this method is that there's no chance for malware to destroy any information. Also, recall we do have a memory image collected already. So we're not likely to lose that much information in this instance. All right, so let's do it. So let's go to our test system, which I already have up and running. And we said, all right, this is my subject system. Of course, it's running in a virtual box. So in this case, I'm just going to call sync, make sure that all the file systems are synced. Since it's running in a virtual box, I'm just going to pull the power it off. Done. Of course, it would be slightly different if you were working on an actual machine. In the next video, we'll talk about how you would image the hard drives from this machine. But that's all for this video. As always, if you're enjoying these videos, please tell a friend. We'll see you next time.